Hi guys, this is for module 5.2, angle, side, angle, triangle congruence. That's what the ASA means, okay? Angle, side, angle. All right, so what does angle, side, angle, triangle congruence theorem tell you about triangles? Basically, if you have two angles and the included side of one triangle are congruent to two other angles and another included side for another triangle, those triangles are congruent. So basically, you have, let's see, your tent right here, and then Jim's tent is right here. Basically, if you had the same angle here as Jim did over here on his tent, and your base of your triangle or tent was the same as Jim's tent over here, and then this angle was congruent to this angle, so we have an angle, side, an angle, then basically your two tents or triangles are congruent to one another. And that's basically what the theorem is saying. All right, so again, there's the theorem and its definition. Again, if you have two angles and the included side of one triangle is congruent to two other angles and an included side from another triangle, then the triangles are congruent. Basically, it's just like the picture I showed you on the last slide. All right, example one, determine whether the triangles are congruent. Okay, so let's see what they gave us. They gave us a 45-degree here. Uh-oh, I don't see a 45. I got a blank space here, though. Okay, so let me think about, let's see, they're supposed to add up to 180, right? So let's go ahead and use that to figure that out, okay? Let's see. We have the measure for angle E, adding up with the measurement of F, adding up with the measurement of D, should give you 180 because the triangle sum theorem. Angle E is 74 degrees. Angle F is 61 degrees. Angle D, we don't know. That's why we're doing this. Should also, I'll add up to 180. Very nice. Let's combine like terms. Got a 5, 13, 113, 135. Sorry, touchscreen's going crazy. I think my dog is whimpering. 135 degrees plus the measurement for angle D equaling 180. Subtraction property. There we go. There we go. Very nice. Cancels out. So we got angle measurement for D equaling 45 degrees. Hey, how about that? So that means this guy is 45 degrees. Okay, so we have an angle. We have an angle. I'm just writing A for angle. Okay, because we're using that theorem. That means we need a side. And let's see, we got a side right here who's also congruent to this 2.3 right here. Because 2.3 is 2.3. Very nice. So it looks like we have a side and a side. And what about the angles? Yep, we got a 61 degrees here and 61 degrees here. There. We also have two corresponding angles that are congruent. Okay, so by S or ASA triangle congruency, these two triangles are congruent. This is always a good marking system right here, how I circled ASA. Okay, so you would say by angle, side, angle, triangle, it's supposed to be a triangle, sorry, congruency theorem, triangle ABC is congruent to triangle DEF. Okay. All right, example two, determine whether the triangles are congruent. Explain your reasoning. Okay, so we got a 31 degrees, matching up with a 31 degrees, that's good. We got a side here that's 60 degrees, as do we here. Okay, so we got an angle, very nice, a side. Again, we have an angle, a side, but that means we need P. Okay, we need that measurement to be the same as this 110 for angle L. Okay, they didn't really tell us what P is, and we can't really assume quite yet that it's not matching up. Okay, so let's see. Triangle sum theorem, right? So if we use triangle sum theorem, we have 38 degrees, okay, plus the 31 degrees. So again, let me set it up. Oh, my dog is going crazy, so let me open up the door and let him out. Here you go, buddy. In about 2 minutes, he's probably going to knock on my door again, crying, "Let me back in." All right. Sorry, my dog is kind of funny. All right, angle N plus angle, remember the measure for M, the measure for angle M, plus the measure for angle P. Thank you, whatever that was. One of these days, I'm going to figure out what that is, and it's going to be great. Until then, I think I'm going to suffer. There we go. So again, they add up to 180. There we go. So measurement for angle N is 38 degrees. Measurement for M is 31. And we're looking for P. That's why we're doing this for the measure. And they're supposed to add up to 180, combine like terms. So we got 69 degrees plus whatever P is. We don't know yet, but we're almost there. Traction property. Very nice. And we got measurement P equaling, looks like 111 degrees. All right, good. But what do you notice? What? Right? That's not 110. So, no. Triangle, was it LJK, not J Kane, is not congruent to triangle MNP. Okay? Since the measure for angle L is not equal to the measure of angle P. So that's the quickest way to make that statement. Make sure I see all your work. If there's homework and whatnot, you definitely want to make sure you write everything out. All right, your turn number 1. So determine whether these triangles are congruent. Explain your reasoning. So just look, just see. Let's talk about it. All right, your turn number 2. Determine whether the triangles are congruent. Same thing. Let's explain your reasoning. Let's see what they got. Can we use triangle sum theorem? What can we do? All right. All right, so proving triangles are congruent with angle side angle. Basically, they give us that, basically, first thing is first is they give us these two angles being congruent to each other. So angle MQP is the same as NPQ. Very nice. That's good to know. And they gave that to us. And then they give us angle MPQ right here is going to be congruent to NQP right here. Okay. And they gave that to us. And then next thing you know, we notice that both these triangles share PQ or QP, right? So that's a side, okay? And that's because of the reflexive property of congruence. Basically, they're both sharing that same line, therefore they reflex across to both of them, okay? So that's a side. Very good. So we have an angle, and a side given to us. And then visually, it's an angle side angle. So yeah, if we got that going on for both our triangles, then our triangles are congruent. So that's what they finish off right here. They say their triangles are congruent because of angle side angle triangle congruency. Okay. All right, proving continued. So basically they give us that angle A and angle C are congruent. So I'm going to mark them. There we go. Okay, and that was given. They gave that to us. How nice of them. And then E is the midpoint of AC. Okay, so that was given as well. So let's see. They gave that to us here, and E is the midpoint of AC. That means that this side has to be the same side or same distance as EC, okay, because this is supposed to be the midpoint. So AE is congruent to CE because the definition of a midpoint. Okay, and that was from step 2. Okay, they told us, these E is the midpoint, therefore these two guys, these two sides have to be congruent. Okay, now I see a vertical angle. I don't know about you, but I definitely see a vertical angle, and that's where it comes off here. Okay, angle AEB, and I just marked them up there, is congruent to CED, and that's because of the fact that they are vertical angles, which is very useful. All right, so we have an angle, we have a side, we have an angle, and let's check the other triangle. We have an angle, we have a side, we have an angle, okay, that are all correspond to each other and congruent. Therefore, these two triangles are congruent, okay, and that's because by angle, side angle, triangle, congruency theorem. Very nice. All right, your turn number 3. So we got a lot here to work with. They do give us they give us an angle, two corresponding angles that are congruent to each other. That's nice. So we got an angle here. Let's see where they go. Angle JLM is here. Angle KML is here. Okay, so we got angles. Okay. And then they give us another angle. Very nice. Angle JML, 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 JLM. I'm trying to figure this real quick. Oh, there we go. Okay, so basically this smaller angle right there, they try to get tricky with us, is congruent to KLM, which is this smaller guy right here. Okay, so we have more angles. Thank you, touchscreen, for doing that. But now we need what? We need a side. Could we use the reflexive property perhaps to get us a side? If so, let me know. Okay, which side can we probably use with the reflexive property? So go ahead. Let's start filling these out. All right, make some statements. They gave us some things. Okay, and we could probably find a side. Okay, so let me know what you got. All right, your turn number 4. They're going to give us. Okay, so they give us some angles. Very nice, and I'm not fixing that. That's just going to annoy you guys subconsciously for a little bit. All right, so angle S is 90 degrees, nice, as is angle U. Okay, and then they tell us that RV bisects SU. That's really good. Okay, so what does that mean? What does that mean? Okay, it's definitely going to get you your side, but you have to figure out what it is. So start with what they gave us. And I don't know about you, but this third part right here for statements, I would probably try to figure out what you can get out of that RV bisects SU piece, okay, to determine what side can you use to use angle side angle triangle congruence. All right, and then also, how can you find your other angle? All right, look at the graph. Do you have any corresponding alternate interior? Do you have I don't know, do you have any other angles that you can see right away just by looking at the picture? Okay, and that should lead you into the rest of your proof. So work on it together, and I'll swoop by and see what you got. Thank you guys, and have a wonderful day. That guy's got life figured out. Really does.